You have typed everything in TypeScript. Your app compiles, everything looks solid until you fetch some data from an API or get user input, and it breaks at runtime. Because TypeScript only checks types at compile time, it can't protect you from invalid data at runtime. That's where Zod comes in, a library that lets you define what valid data looks like and verify it at runtime. In this video, I'll show you how to use a tool that generates Zod schemas automatically from your TypeScript types using real-world examples like API responses so your app is safe from bad data and you don't have to write everything twice. So first thing first, what is Zod? Zod is a TypeScript-first schema declaration and validation library. It helps you define what valid data looks like and ensures anything unexpected gets caught early. So let's go to Visual Studio Code, write some code, and see for ourselves. We are going to start by creating our project. So I'm going to call it Zod with TS. And first, we need to step into this and initialize it as an npm project folder with command npm init-y. Okay, next we need to install Zod as instructed on the Zod homepage on npmjs.org. So this is the command npm install Zod. So I'm going to copy and paste it. Okay, Zod is installed, but since we are trying to use TypeScript, let's install TypeScript as well as its companion library ts-node, which would let us execute TypeScript files directly. While it installs, let me quickly say that I am assuming you know how to write TypeScript. If not, our channel has a 90 minutes TypeScript crash course which you can watch to get familiar with everything I'm doing and more. Alright, with TypeScript installed, we need to create the tsconfig to set it up properly, which is done using the command npx tsc -init. Okay, everything is good. Let's open it in Visual Studio Code using code dot. Here we are. All right, now we need to create a new TypeScript file to contain our code. Let's call it ts-zod.ts. I'm going to create it in the root. All right, now either follow what I type or copy and paste the example from Zod homepage on npmjs.org. So let's do it like this. So here we have imported Zod/v4 library, which lets us use Zod library constructs, and we are using z.object function to define a Zod schema, describing what our expected input should look like. So we are using z.string and z.number functions to define name and age properties in the schema object, where we say we expect name to be a string and age to be a number. In the next line, we use schema.parse function and provide a test object to see if Zod lives up to the hype and identifies any issues with our input object. Note it's not going to output anything if the parsing is successful, but it would fail with a big error if it finds any issues. So let's set it up so it always writes something to the console. Right, time to give it a try. I'm going to open the terminal and we are going to use ts-node and provide a file name ts-zod.ts and hopefully, oh, sorry, my mistake. I needed to add npx prefix. And here we are. Since the object we provided as input totally conformed to our expected schema, we see the object being written out as is. But let's make some change and let's introduce double quotes around 30 to make it a string instead of a number. And let's see what happens. All right, what happened here? All right, so now it's giving us an error, Zod error, where it says expected number, code is invalid type, and it's giving the property name, and the message says invalid input, expected number, received string. Perfect. It worked exactly as it should have. Zod is your best friend when dealing with user input, API responses, or anything coming from the outside world. Now that you have some idea how Zod works, let's go over the biggest pain point most developers experience with Zod. Let's say you already wrote your types in TypeScript. Now you have to write the same thing again just to validate. Let's say I modify this file like this. Now we have the type user and the schema on line 5, which is exactly the same thing, but had to be redefined to parse the input for the type user. Wouldn't it be better if the Zord schema came directly from your existing TypeScript types? That's exactly what the tool Ts-to-zod does. It reads your TypeScript files and spits out equivalent Zord schemas. Okay, let's see that in action. So we go here and we type. Okay, let's take a real world example. Say you are fetching users from an API like JSON placeholders. To see that, let's create another file called real API example.ts. Let me type and then I'll explain. This file includes a type, a function, and a class, just like you'd have in a real code base. Let's generate a Zord schema from that file, and we are going to use ts2zod this time. I'm going to open the terminal and say npx. Okay, we have a new file zordschemas.ts. If we open it, we can see it automatically picked up the exported user type and generated a matching schema. As you can see, our actual example had an exported type, an exported function, and a class. Ts2zod ignored the functions and classes, only types were converted. I added those extras in input file to demonstrate how Ts2zod can work on real TypeScript files that you normally write, not just isolated examples, and you see how amazing and practically useful this feature is. Finally, in case you are wondering why type user with capital U resulted in user schema with small u, well, that's Ts2zod convention, and I am as mad as you are, so be angry at them and not me. All right, let's fetch some data from the actual API and validate it. So to do that, I'm going back to my real API example.ts and I'm going to add another function called getUser. Okay, as a final step, we need to import this user schema from our zordschemas.ts file. Here we go, right? Uh, all is left is to call this getUser function, save, terminal. Boom! Runtime validation with full type safety, straight from a real API. The cherry on top is the safeParse function that we used instead of parse on user schema object over here. This is a legit way to parse without errors being thrown. If you see at the result, you would notice the returned object has a success property, which is true since our input was conformant to the schema. But otherwise, you can check this success property instead of resorting to try-catch blocks to determine if parsing succeeded or failed. Furthermore, the magic here is that your types and your runtime validation are always in sync. You only define the structure once. You can even run Ts2zod in your CI pipeline to catch mismatches automatically. Finally, there are a few things to watch out for. First, complex types like generics or recursive types might need some tweaking. I won't go into details here, but just keep it in mind. Second, regex, refinements, and branded types aren't automatically included. You'll need to add those manually. And finally, only the exported types are picked up, private or internal types are skipped. But for 90% of everyday dev work, this tool just works. To recap, use Ts2zod to auto-generate schemas from your existing types, even in real-world files. Validate API responses with confidence, and never write redundant schemas again. If this saved you time, please like and share, and subscribe to be notified of content like this one and more. Thanks for watching. Goodbye. A few things to watch out for. First, complex types like generics or recursive types might need some tweaking. I won't go into details here, but just keep it in mind. Second, regex, refinements, and branded types aren't automatically included. You'll need to add those manually. And finally, only the exported types are picked up, private or internal types are skipped. But for 90% of everyday dev work, this tool just works. If this saved you time, please like and share and subscribe to be notified of content like this one and more. Thanks for watching. Goodbye.